All right, we are on page 45 in your notebook, and our goal for today, our objective for this lesson, is to be able to factor a quadratic trinomial. Remember that a quadratic, going back and remembering our vocabulary, means that the highest degree that we have is to the second power. So this makes this a quadratic. And then trinomial means that we're going to have three terms. So we have 1, 2, 3 terms. And the types of quadratic trinomials that we're going to be looking at in this lesson focus on when our a value, which we call our leading coefficient, is equal to 1. So our problems are going to start as 1x squared. In our weekly review video, we'll start to talk about how we decide how to start a problem using our flow chart, thinking through the process. But right now for this new video, we're going to look at just being able to do these types of problems, okay? So when I look at this problem here, I see that it is a quadratic because it has to the second power, and that there are 1, 2, 3 unique terms. None of those are like each other. I cannot combine any of those. And that my leading coefficient is equal to 1. Now, keep in mind that our goal is that by the time we finish, we want to know what are the two factors that when multiplied together create this quadratic binomial. And so we are going to use the idea of that multiplication box method, but we're going to think about it in reverse, okay? So I'm going to take a second and I am going to draw a 2 by 2 box. You go ahead and do that as well. Now, what I'm going to do is I'm going to take and put this first term right here in this upper left box, and that's going to be x squared. And then I'm going to take this last term, 15, and I'm going to put it here. And so in the bottom right box. Now, I'm going to have to think about that 8x, but for a moment here, I'm going to start with the x squared. And x squared, when I go to factor it, can only be the product of x times x. Okay, now what I'm going to do is I'm going to look at the other number that I have in the bottom right-hand corner, which happens to be a 15. And I'm going to think about, or I'm going to list out the factors of that number. So the factors of 15 are 1 times 15 and 3 times 5. You could see that sometimes when there's just two sets of factors, thinking might be okay, but for most problems, we are going to want to list out these factors. Because what I want to do is I want to select a set of factors so that when I multiply them back together, they're going to create this middle term right here, which is 8x. So if I look at my factors here, I have 1 and 15. Well, 1 plus 15 will give me 16. And I need 8. But if I look at the factors 3 and 5, if I add those together, that gives me an 8. So I'm going to write down a positive 3 and a positive 5. And then I'm going to see if this works. So if I take x times positive 5, that's going to give me 5x. If I take 3 times x, that's going to give me a positive 3x. So let's check ourselves. If I were to combine like terms, would I get back to this original quadratic trinomial? So I would have the x squared, doesn't combine with anything, but here it is in my original. I would have 3x and 5x, and those when combined give me 8x, which is what I wanted. And then I have 3 times 5, which is 15, which is what we had. So what that tells me is I now have enough to create my answer. If I would go ahead and write my two factors, my one factor is going to be right here, x plus 3. And then my other factor is going to be right here, x plus 5. So now this is my answer. It is the factors of this quadratic trinomial. Keep in mind, just like we've worked before, that if you were to have written out your answer and you had written that this was x plus 5 times x plus 3, that this is the exact same thing. That multiplication property is what we call commutative, and so the order does not change the product. Okay, let's look at a couple more examples. All right, so we are on problem number 2 on page 45, and our problem is x squared plus 11x plus 24. So we can see that this fits into a quadratic trinomial. So we have a x to the second power is our highest degree. We have 3 terms and our leading coefficient is 1. Okay, so I know that it fits this type of factoring, and so I'm going to start by drawing a 2x2 box. And then I'm going to look and say, well, this first here is an x to the second. So x to the second goes here. And I could, if we automatically know that that's going to be an x times an x. So we can go ahead and put that in. Now, what we're going to look at here is this plus 24 is going to go here. Now, I'm going to have to think about the factors of 24. And this is one we're actually going to list. So because we have 1 and 24, we have 2 and 12, we have 3 and 8, and we have 4 and 6. And then I'm going to examine my factors, and I'm looking for the factors that would add together to get me an 11. So I want that 11 right there. So if I look at this, 1 and 24 would give me a 25. 2 and 12 would give me a 24. But look at this, 3 and 8 give me an 11. So I'm going to take and put that. This is a positive 3 and a positive 8. Now I just selected where to put the 3 and the 8. I could have those switched around also. So let's see if this works. If I were to multiply this times this, that would give me a positive 3x. And this times this would give me a positive 8x. Now let me see if this works backwards when I combine my like terms. I'm going to have, here's my x squared. There it is. When I combine these, 3x and 8x, that's going to make 11x right there. And there's our positive 24. Okay, so that tells me that I have the correct set of factors, and I'm now able to write my final answer, which is going to be this factor here, x plus 8, and this factor here, which is x plus 3. Okay, remember that if you wrote this as x plus 3 times x plus 8, that is the exact same thing. You don't need to write both of those. We just have to recognize that they are the same, and that now these sets of factors here, if multiplied back together, will give us this original quadratic trinomial. Okay, all right, so let's look at another problem. And we first want to look and make sure it fits into the types of problems that we're doing. And so we can see that ax squared plus bx plus c. Now you might say, well, hey, that b term is negative, and that's fine. We're just looking to make sure that it has a square term, and then a x term, a linear term, and then a c, a constant. Okay. All right, so I'm going to now look at this and say that need to take and draw a 2x2 box. Okay, and I'm going to take, and the first thing that I'm going to do is take that x squared and say, well, that is x times x. And then I'm going to take the positive 24, and now I'm going to think of the factors of 24 again. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay. Now this time, I'm looking for the set of factors that will make a negative 11x. So what that tells me is that I'm looking not just for them to add to 11, but add to negative 11. So when we think about this, then what that means is that I'm still going to go with the 3 and the 8, because that will give me 3 and 8 will give me 11. But if I want a negative 11, it's going to be a negative 3 and a negative 8. So that when I multiply this times this, that'll give me a negative 3x. And when I multiply this times this, that'll give me a negative 8x. And so let me go and check to make sure that I've done this correctly. Here's my x squared. There it is in the original. If I combine these, a negative 3 and a negative 8 will give me a negative 11. And there's my positive 24. So I'm going to be able to say that my answer is going to be x minus 8 times x minus 3, or if you have it the other way, x minus 3 times x minus 8. And once again, what we have found is that when you multiply these factors together, you would end up with that original quadratic trinomial.